So the last thing we talked about on the last little section was dealing with the fact that the atomic mass is equal to the protons plus the neutrons. All right, so the protons plus the neutrons has nothing to do with the electrons. Now, what that can create is the fact that the protons of any atom never change. Okay, we never have any changing of the protons. If it does change, and certainly there are cases where the protons will change. We're going to get into that in this unit where it's decay, but they never change if it's going to remain its same thing. If it's got a change of protons, it's a new substance. But basically, you can get a different number of neutrons in the same atom. So you've got carbon's always going to have 6 protons, because if you look at the periodic table, there's going to be 6 protons. But the neutrons, you can have a different number, and it could still be carbon. And what that's called is isotopes. Isotopes of each other. So an isotope is same element, same atom, I guess we could say element, but different number of neutrons. Same element, but different number of neutrons. So let's take a look at an example. Carbon. Carbon actually has 9 different isotopes. Here are 3 pretty common ones, but 9 different isotopes. What that means is, even though it's still carbon, even though there are still 6 protons, there are a different number of neutrons. This number in the upper left corner, when you write a chemical symbol, is the atomic mass. And I probably should be even more specific, the mass number. The mass number. And since the atomic mass, or the mass number, is the proton plus neutrons, this 12 relates only to the protons and neutrons, ignoring all electrons, because we say that electrons have a negligible mass. Let's go ahead and create a little chart here as we look at these 3 different isotopes of each other. Protons, electrons, and neutrons. Okay, so how many protons are there in each of these? Well, hopefully we're in the comfort level saying there are 6 protons. Why? Because carbon on the periodic table is number 6. Okay, it's the atomic number, it's the whole number, it's the number on the periodic table that describes how many protons there are. So all the same number of protons. Now, in this case, the electrons would have to be the same. We would have 6 electrons in each of these. Now, the reason we know that there are 6 electrons is this simple. Because it's an atom. How do I know it's an atom? There are no charges on it. If you recall from the previous unit, we talked about writing ions. And if there's no charge, notice that there are no charges on each of them. In the upper right corner is where we would write the charges. And since there's no charge, then that must mean that the protons equals the electrons. If there are no charges, the protons and electrons equal each other. So there's 6 in each of these because there's 6 protons. The neutrons, well, the neutrons, if this number in the upper left corner is the, again, mass number, which is the protons plus neutrons, really all you're doing is a little math problem. You've got 12 for a mass, and if you have 6 protons, then you must have, in this case, 6 neutrons, because protons plus neutrons add up to your mass. Okay, so in this case there's 6. Here our mass is 13, so we would have 7 neutrons. Here we would have 8, because again we're adding up our protons and neutrons in each of these, and notice the respective sums of the protons and neutrons. So those are isotopes of each other. Now, I didn't write a fully complete chemical symbol because I wanted you to know that I didn't have to write the number of protons on this substance. The number of protons you can just look on the periodic table and it tells you. But to write a complete chemical symbol, let's say I have mercury, and mercury is number 80, and it often has a mass of 200. Notice I wrote an 80 down here. This is where you write the atomic number, or in other words, of course, the number of protons when you write a chemical symbol. So lower left corner is where you would, kind of like a subscript on the left side, write the number of protons. So there would be 80 protons in this symbol. The electrons in this case would also be 80 because no charge, protons equal electrons. And lastly, this number right here is our protons plus our neutrons. If we have 80 protons, then we must have 120 neutrons, because those two added up would of course give us our mass. Okay?